Okay, second part of this lesson is the factor theorem. Now, I said the factor theorem was a nice little shortcut for the algebraic long division. Let's have a quick look at the theory before we get into it. If 12 divided by 4 is 3 with no remainders, then we know that 4 is a factor of 12. It divides into it nicely and evenly, nothing left over. Now, from the previous question, we had that x minus 1 divides into x cubed minus 4x squared plus 3x, and there was no remainder. Then we know that x minus 1 must be a factor of x cubed minus 4x squared plus 3x. No remainder. It divides in, it must be a factor. Now, algebraic long division can be used to decide whether a linear expression, so that's your x minus 1, is a factor of a higher order expression, so a quadratic or a cubic, in our case, a cubic. But there is a quicker way to do it, and that quicker way is the factor theorem. And the factor theorem states that if f of k is equal to 0, then x minus k is a factor. This is going to seem a little bit abstract until we get into doing a question. Basically, this linear here, if it's a factor, whatever bit is here at the end, if you sub it into the function, but change the sign, I'll tell you more about this, but change the sign, then if when you sub it in, you get 0, you can say that that linear part here is a factor. And then you can extend that a little bit to say, well, if it's not just x minus k, but if there's a number in front of x, if it's ax minus k, f of k over a is equal to 0. Watch the sign change. This might seem a little bit abstract and confusing. Let's do an example and figure it out. So the question says, if x minus 1 is a factor of x cubed plus kx squared minus x minus 8, find the value of k. Now you can see here, algebraic long division would be a little bit tricky, not impossible, but a little bit tricky because you don't have all the information. So our factor theorem, let me just copy it down here again. Okay, so our factor theorem tells us that if f of k is equal to 0, then x minus k is a factor. Now what's our x minus k? Our x minus k is x minus 1. If we look again, we've got an x minus k here, and we've got f of positive k. So ours then would be, we have an x minus 1, so it would be f of positive 1 is equal to 0. So that's how we've turned the factor theorem into to suit our particular question. So what am I going to do with this? This is our function. We're going to call this function f of x. It's a function of x. And f of x, that's just notation. Equally, we could call it y. But because we've got this f of 1 notation, this f of k notation, let's stick with f of x instead of y. X cubed plus kx squared minus x minus 8 is f of x. And the factor theorem told us that we should do f of 1. That means replace x with 1. X there becomes 1. That x, that x, that x all becomes 1. So we sub in 1 here, 1 here, and 1 here. And we know that if x minus 1 is a factor, then f of 1 is equal to 0. So this is f of 1, it should equal to 0. Let's do a bit of work. 1 plus k minus 1 minus 8 is equal to 0. The 1 minus 1 is gone. What am I trying to do? I'm trying to find k. Now look where I am. I have an equation with k, negative 8 added on the other side. There you go. K is 8. So in these questions, you might necessarily see a few steps ahead, but you just see the words x minus 1 is a factor, and you should be thinking either long division or the factor theorem, one of those. You do them, and then things just kind of work out. So write down that worked example, make sure you've got your title on the top of the page, and when you're ready, have a go at the question on the right. It's a little bit of a level up, this one now. You'll notice in your function, you've got two unknowns, an a and a b, but you're also given two pieces of information. You're given two factors. So you can do this f of k business twice. And once you've done that, something might become clear on how to move forward. Have a go. Don't just watch me doing it until you've had a good go yourself, okay? It's really important for your learning that you're pushing yourself on. If all you're doing is watching me doing maths, you're learning very little maths. If you're doing the maths with me or ahead of me, you're learning a lot more. Okay, let's go. Okay, scroll back up again to see what we were asked, because you just get buried in these things, don't you? And you forget what the question actually said. It said, find the values of A and B. That is what I was asked. And down here at the end, I found the values of A and B. So we're done. Now, in that one, we just did our factor theorem stuff. And we reached a point where we had an equation with two variables, and well, what are you going to do with that? You're going to need another equation to go with it if you've got two variables. So we did the factor theorem stuff again with the other information they gave us. We ended up with two equations, two variables, solved them simultaneously. Job done.